Whoa, did you guys notice that today's Friday the 13th? Don't get axe murdered today, okay? I know, that's a goal really for every day, right? Nobody really wakes up in the morning and like, let's get axe murdered today, right? But on a day like Friday the 13th, you have to be extra careful. So don't cross any black cats or walk under any ladders or break any mirrors or anything else to make your luck any worse. I think it all cancels each other out then, and you're okay. If you manage to do all that at the same time. So I think you're okay if that happened. So Victoria, I'm going to start by just kind of trying to get the tangent part by itself. So I'll add 1 to both sides. And then divide both sides by 3. And then we'll square root both sides. So when we square root both sides of an equation, it creates a plus or minus, and the square root of 3 we'll just write as the square root of 3. And so I'm going to break that off into 2 pieces. So I'll have tangent is equal to this, and then tangent x is equal to negative square root of 3. And then we'll apply our inverse. Okay. And now I would be going, or attempting to go to the unit circle to look up the angle measures here. Now, remember that tangent is y over x. So in this case, if I'm talking about like the square root of 3, my y is the square root of 3 and my x would be 1. Now, there's no point on the unit circle that has those exact y coordinates, right? We have a point that's close. So if I divide the top and bottom of this fraction by 1/2, I get square root of 3 over 2 over 1/2, because those are actually coordinates on the unit circle. Is that okay, Victoria?
Yes.
Okay. Is everybody else okay with what I did there? So I'm just trying to make it a little bit, spell out it and make it a little bit more obvious how I'm locating this coordinate for tangent. So I go to my unit circle, and I find the place where the x is 1/2, and the y is the square root of 3 over 2. Let me just double check that because I don't want to. So the y, okay, good. Y is 1/2, or the x is 1/2. And in fact, that's all I really need to remember, right? So I have 1 at pi over 3 and 5 pi over 3. And if I do the same thing with negative, the negative sign could be on the 1/2 or it could be on the square root of 3, right? So either is okay. And in fact, I wrote that 5 pi over 3 in the wrong spot. So we'll just go back and get that. Anyway, so I can have x is 1/2 or negative 1/2. It doesn't really matter for each of these. So this is my other one's 2/3. This is the other one 4/3, and this is the other one 5/3. So those are the 3. So I have 1/3, 2/3, 4/3, and 5/3. So I have 1/3, 2/3, 4/3, and then 5/3. Yes, you could. So that those 4 are our answer for A. I'm just going to leave it this way because so it's obvious when you're looking at the notes, like where those came from, like which part I got those answers from. But yeah, you could write them all as one single list, and that's no problem at all. And the order of you write them on that list doesn't matter either. So whatever is fine. Victoria, is still okay?
Oh yeah, I'm good.
Okay. Yep. Okay. I'm just checking because it was your question. I see your head down. You're writing stuff, so I don't want to bulldoze past it if you're still processing. Okay, so part B is we're looking at the interval of all real numbers. So all I need to do there is just take each of these answers and on a 2 pi k at the end of it. But if I look real closely here, I could do a little bit better than that. For example, pi over 3 and 4/3 pi over 3 are pi apart, right? So if I continued and went another pi from 4 pi over 3, I would be back at something coterminal to pi over 3. So really, I could combine these into one answer that's just pi apart. And similarly down here. Now, on a test or whatever, I wouldn't mark this wrong if you didn't do this. But if you're taking like a multiple choice test, they would surely combine these as to like a single set of answers and not 4 separate answers. Keaton? So if you look on the unit circle, like, you know, pi over 3 is here, and maybe 4 pi over 3 is here. So that's pi will get us to that answer. And another pi will get us back to that answer. So, yeah, exactly. So I can just list this as a single answer that's every pi units I'm running into an answer. Does that kind of make sense? And I can do the same thing with the other pair. So it's just combining them into a single answer. I haven't done anything. This stuff that I wrote initially, where I had 4 answers plus 2 pi k, is still correct. It's just a little bit more compact the other way, which as mathematicians we prefer that, but it's not any less correct before than it is now. You know what I mean? It's like if you wrote your fraction as 2/4, like I'd make fun of you for not reducing your fraction, but it's not wrong, right? It just, there's a better way of writing it. That's all. Okay, so for part C, we're talking about the interval from -2 pi to +2 pi. So notice that our answers for part A are from 0 to 2 pi, right? That interval is inside of the interval for C, correct? So all of our answers for part A will also be answers for part C. That'll be true always for all of these problems. The part that we haven't dealt with yet then is that interval from -2 pi to 0. That part we haven't found out if we have any answers in, right? So to find those answers, all I'm going to do is I'm just going to subtract 2 pi from each of these and check to make sure that it's in that interval. I'm subtracting because I know that 0 to 2 pi is less than, or -2 pi to 0 is less than 0 to 2 pi, right? So if I do that, I get -5 pi over 3. That's still bigger than -2. I get -4 pi over 3, still bigger than -2. -2 pi over 3, and then -1 pi over 3. And if I tried to do that again, if I subtract 2 pi one more time, everything's going to be too small, right? Since all of these are negative, if I subtract another 2 pi, I'm definitely going to have something smaller than -2 pi, right? So I'm done. Everybody okay with that? And if you wanted to, probably on the answer key, if I were to write this, I would just write these as like plus or minus, each one of them. Since this answer here, I have the positive and negative versions of it. Doesn't always work out that way, but it could. Everybody's okay there? All right. The last part I think the interval is negative pi to 4 pi. So definitely 0 to 2 pi is inside of that interval. So all of our answers for part A are still going to be valid answers here for part D. Okay with that, Victoria? And some of our negative answers for part C are going to be valid here also, right? But not necessarily all of them, because we're only going down to negative pi, not all the way down to negative 2 pi. But all I'm going to do is just look from the list and just take the answers that are bigger than negative 2 pi. So those two I can also take without having to do anything more than just like looking at my previous answers, which is nice, right? As much as I can harvest from those other answers, the better. But that does, I've taken care now of like negative pi to 2 pi. All of that stuff has been taken care of. So the only part of our interval we still have to worry about is that 2 pi to 4 pi part. And the way I'm going to find that is just looking at stuff that's coterminal to each of these. This time, since I'm looking for bigger answers, I should be adding 2 pi. So if I do that, I get 7 pi over 3 for this one, and then 8 pi over 3, and then 10 pi over 3, and then 11 pi over 3. And 12 over 3 is the same as 4. All of these are less than 4 pi, so I'm good. But since they're all bigger than 2 pi, if I add another 2 pi, they're going to be bigger than 4 pi. So I know that I don't have any other answers past these ones. So that's it. It's these 10 are my answers for part B. Is that okay?
Yes.
You're welcome. And again, although there's a lot of parts to do here, once you have part A, the rest of this is like, should go relatively quickly, right? To get your answer for part B, basically all you're doing is tacking on 2 pi k's, right? For part C, you're just taking your answers from part A and then finding the next set of coterminals that are less than those ones, okay? And then for part D, you're looking at your answers from part C, taking everything that's inside the interval still, and then looking at one more coterminal bigger than the stuff from part A. Haley? Sure. Did that help in general, everyone? Does that at least help maybe make yourself a little bit more efficient while you're doing this, right? Okay, so we have sine squared x equals 6x minus 5. Okay? So this looks a little like a quadratic, right? Because I have sine x and sine squared x. To solve a quadratic, I know that it has to equal 0. So I'm going to subtract everything onto one, or move everything onto one side. And then I notice this looks, as we mentioned before, a little quadratic. To really point that out, I'm going to do a little substitution here and replace my signs with a's, just so it's really obvious that this is quadratic. Everybody okay with that? So the ways to solve a quadratic, where you have both squared and non-squared terms, like this one, you're either going to factor it or use the quadratic formula. Now, since the leading coefficient is 1, if it's factorable, it's going to be really easy to factor it. So let's try to do that. So we need two numbers that multiply to give us positive 5 and add to give us negative 6. Those two numbers are negative 1 and negative 5, right? So do that. And then I can apply the zero product property and set each of these factors equal to 0 and solve them independently. But remember here, we're solving for sine, or solving for x and not a. So let's go ahead and substitute sine x back in place of a. And then I can find the inverses to get the x by itself. Everybody okay there? So sine inverse of 1, I'm going to go to my unit circle and look for the place where the y-coordinate is 1. That happens just one place at pi over 2. And then I have sine inverse of 5. This has no solution because I know that the domain for these inverse functions is -1 to +1. I can't take the sine or cosine inverse of something that's smaller than -1 or bigger than +1. So this just is equal to undefined. There's no solution from that part. Is that cool, Haley? Okay. So that's our answer for part A. We just have one answer. For part B, all we have to do is tack on a 2 pi k to that. For part C, I just need to subtract 2 pi from that. That's all I have to do there. And then from part D, I notice that this answer is too small. So I'm not going to include the -3 pi over 2. But I'm also going to add 2 pi to this one. So that's going to give me 5 pi over 2. And if I try to add another 2 pi, it's going to be too big, right? I'm at 2.5. If I add 2 pi more, I'd be at 4.5, which is too big. So that's it for part D. So the trickiest piece was like what to do with this. Yep. So if you did nothing with it, that was the right decision because you can't. Again, remembering that the domain for, sine inverse is -1 to +1. So if you try to take sine inverse of something that's too big or too small, it doesn't work. Keaton. Yeah. Anthony, you had your hand up also. Is this a separate question or related to this one? Okay, that's fine. Before I moved on, if you had a question about this one that we were on, I didn't want to have to backtrack or anything for it. You know what I mean? So here's this one, 35. So it's basically the cosine part is already isolated, so I can go straight to the inverse. But since I have a coefficient on my x, it's not quite as easy as the ones where the coefficient on the x is just 1. So I'll go to my unit circle here. I'm going to look for the places where the x coordinate is square root 3 over 2. So I have pi over 6 and 11 pi over 6. But there could still be other answers because of that coefficient. So I have to be a little bit careful there. So I'm going to do that plus 2 pi k here right now. And when I divide both sides by 2, I divide the 2 from both the angle measure and also from that piece that's giving me the coterminal part. So those go down to pi over k, or pi k's. So when k equals 0, I have to worry about any negative values for k because we're still in part A solving for the interval, 0 to 2 pi. So I have pi over 12 and 11 pi over 12. When k equals 1, I'm going to get 13 pi over 12, which is still good, right? That's still in between 0 and 2 pi. And then I'll have 23 over 12. Again, still less than 2 pi. But if I did it again, everything would be too big, right? So keep in mind that I added pi each time instead of 2 pi there. And the reason I did that is because when I divided both sides by 2, it shrunk down that coterminal piece as well, right? So there's my answer for part A. My answer for part B we've already found. It's just that piece up above. So we ended up finding this out of order this time because we needed the coterm to find those extra answers for part A. For part C, again, we have all of our answers for part A. And then we have to worry about subtracting, right? Because we still have to worry about the interval from negative 2 pi to 0. So I'm going to subtract 2 pi from subtract pi from the first one. That's going to give me negative 11 pi over 12. And I'll subtract pi from that one. That'll give me negative pi over 12. Both of those are good. So, and since they're both are bigger than negative pi, I'm going to do it again. So if I subtract pi from negative 11 over 12, I get negative 23 pi over 12. If I subtract pi from negative 1 over 12, I get negative 13 pi over 12. If I tried to do that again, they'd be too small, right? Since both of those are less than negative pi, if I subtract another negative pi, I'm going to get something less than negative 2 pi, which is too small. So that's my list for part C. For part D, I know I'm going to need all of my answers from A. So I'll write those down right away. And then I'm going to take all my answers from D that are bigger than negative pi. So that's just those two. Okay with that? And then I still have to worry about the part from 2 pi to 4 pi. So I'm going to take my biggest two answers and add pi to each of those. So that's going to give me 25 pi over 12 and 35 pi over 12. Both of those are smaller than 3 pi. So I'm going to do it again and add another pi to each of those. So that's going to give me 37 pi over 12 and 47 pi over 12. And since 37 pi over 12 is bigger than 3 pi, I know I can't add another pi to this, or else I'll get something that's too big. So I'm going to be done here. So there was a lot of them for this one. Look at all those answers. You're welcome. Anthony, your turn, my man. 38. Sure. Okay. So here we have two different trig functions. Oh no. But don't fear, we can remedy this and turn it into a single trig function using our identities. So what I'm going to do is I'm going to divide both sides by cosine squared x over 3. Okay with that? And I know that sine squared theta over cosine squared theta is tangent squared theta. Is that okay? So that was one of my quotient identities from my identity sheet. They will occasionally come in handy on these solving problems. That's why they're in the same section. So then we'll square root both sides. And then we'll have to split this into two equations, one with the positive square root 3 and one with the negative square root 3. So x over 3 is equal to tan inverse of square root 3 and x of negative square root 3. And this is the same situation. We ran into this situation just a few problems ago, so I'm not going to re-explain. I'm just going to go straight to the unit circle and copy these down. Is that okay with you guys? In fact, I'm not even going to go straight to the unit circle. I'm just going to cheat and go back and look at the previous problem where this happened. So it was pi over 3 and 4 pi over 3, 2 pi over 3, and 5 pi over 3. So, what I'll do then is I'll think about these each as their infinite solution. And again, I'm just writing a lot of this out because it's more clear. Obviously, you don't need to show all this work. I think it's relatively obvious what's going on here, but we're going to do it that way anyways. So to solve for x, I'll multiply both sides by 3. Okay, there. And then for part A, if I set k to be 0, the only one that's inside of our interval is pi. Why is 2 pi not in the interval here? Because if I look at the directions, it's a parenthesis on the 2 pi on my interval, so 2 pi is not included. So because I have exactly 2 pi here, it doesn't get to go in. Is that okay? Our answers for B are right here. Or if you wanted to, you could combine them together and just say like, well, that's whatever. We'll just, you could do some combining, but those answers are fine. And then we have negative 2 pi to positive 2 pi. But notice on the interval for C, the bracket is square on the 2 pi. So we pick up that extra solution there. And we're going to pick up some of the negative coterminals. So like when this one, the k is negative 1, I'll get negative 2 pi. And this one, when k is negative 1, we'll get negative pi. So we pick up those also. Everybody's okay there? Anthony, you still doing okay? Okay. And then for D, our interval is negative pi to 4 pi. So let's see, we're going to get pi, we get 2 pi, we get negative pi from that list, but negative 2 pi is too small. And then we also are going to get, oh, nothing else, right? Because it's a parenthesis at 4 pi, we don't get an answer from here. So that's it. Well, 3 pi is not on my list, and I can't make 3 pi by adding 6 pi to any of these, or subtracting 6 pi from any of these. So 3 pi doesn't make it. Is that okay? Josh. 18? Sure. Yes, sir. Of course. So I have that. So I'm going to go in my unit circle and look at places where the y coordinate is 0. That happens at 0, pi, and then again at 2 pi, but again, I don't need to worry about that because the interval's a parenthesis there. For part B, I could tack on plus 2 pi k's to each of these, but if you notice, I have 0, and then pi, and then 2 pi, 3 pi, 4 pi. So they're all just pi apart. So I would just write it condensed, since it's really easy to see that. Yeah, you're welcome. Victoria? Sure. Does this sound good being the last question? I'll just let you guys work on stuff the rest of the hour, and if you run into individual stuff, you can come and ask me individually. Does that work? Yeah. Okay. So I think we've done a good chunk of these and covered a lot of the tricky cases. So you're looking at 13. Is that correct?
Yes.
Okay. So if I look at 13, can I cross out the cosines from the numerator and denominator? Absolutely not. Why not? Because of the addition and subtraction going on in the denominators, right? So you can't cross out part of an addition or subtraction problem. You can only cross off multiplication parts, right? Okay, so there's no canceling to do here. Is there an obvious identity that I could use? Doesn't seem like it, right? I mean, you could rewrite the cosines as like 1 over secants or something, but like now you're talking about making fractions inside of fractions, and that seems like it's just going to make things a little worse. You guys buy that? Okay. So let's look for another algebra thing to do. Elizabeth. Sure, we can make a common denominator. What would the common denominator be in this case? Okay, and how am I going to turn each of these into that? So the cosines distribute there. So I end up with cosine plus cosine squared x plus cosine minus cosine squared x. And then if I FOIL that out, you'll end up with 1 minus cosine squared, as Elizabeth stated earlier. I'm just not going to write out all the foiling if that's okay with you guys. Hopefully you just recognize that as a difference of 2 squares and just apply that factoring pattern to do the multiplication. But if you don't and you FOIL it out, that's fine. You'll end up with that same thing. So hopefully right away you notice that the cosine squareds are going to cancel out in the numerator. So we're left with 2 cosine over 1 minus cosine squared. So far, so good? Okay. So 1 minus cosine squared, I recognize that as a modification of the first Pythagorean. So you notice, remember, the first Pythagorean identity is this. If I subtract cosine squared from both sides of that identity, I get that sine squared is equal to 1 minus cosine squared. So that's what I'm going to use here. You okay with that? Okay. And now what I'm going to do is I'm going to think about the problem this way. I'm going to think about 2 over cosine x times sine x times 1 over sine x. The reason I'm going to do that is because it's going to allow me to get rid of the fraction entirely, because I know that cosine over sine is cotangent, and 1 over sine is cosecant, and that's really the best that I can do there. We still have 2 trig functions, but at least we took care of the division, right? Typically, a multiplication problem is better than a division problem. You know what I mean? Did that help, Victoria? Of course. So we'll stop here. You guys can continue working on whatever parts of the homework you still need to work on. If you run into things that you want to ask questions about, or you want me to check your work on, or anything else, let me know. I'm happy to take individual questions here, but from here on out, it's going to be individual stuff, okay? You ladies that are working from home on Zoom, you can go if you'd like. We're just going to be working on homework assignments. Obviously, you don't have to leave. You can certainly stay if you have questions or anything. Let me know. But if you want to go somewhere more comfortable to work, that's perfectly fine. Okie dokie. Okay. I don't know.